Warm welcome you all to channel Meet MIT, that is Math is Tricky.
In this video, I'm going to share some tips and tricks about binomial theorem. Okay, so first I will explain what is binomial theorem, why do we need binomial theorem, what is its importance, and what are the applications of binomial theorem, how can we easily remember binomial theorem, and then I'll be solving some problems based on binomial theorem. Before solving the problem, let me explain what is actually binomial theorem. So suppose here a plus x power is 1. So what will be its answer? A plus x, isn't it? So now if you have to find the value of a plus x power 2, that means a plus x whole square. So it will be simply, we know a square plus 2 ax plus x square, isn't it? So if the power is here 3, we have the answer a cube plus 3a square x plus 3ax square plus x cube. Okay, so now my question is, if the power is increasing, if the power goes on increasing, what will be the answer? Suppose you have to find a power x whole power 20. So now how do you write this? If power increases, suppose a plus x power 50. So now will be your answer. So now it means here, if power goes on increasing, it will be difficult for us to write. Okay, so now it means here we need a formula, we need a theorem, so that we can write answer for any power of the expression a plus x. Suppose a plus x power n is there, what will be your answer? A plus x power n. So what will be the answer for this? How can we write this? So now this is why we need now a theorem, that is called binomial theorem. First it was proved by Isaac Newton. Now let me explain here, and then I'll be writing the formula for this. It means here some points, let's note down some points, then I'll be writing the binomial theorem. So first see here, if power is 1, here we are getting here 2 terms. Okay, if power is here 2, we are getting here 3 terms. Now if power is 3 here, so we are getting 4 terms. Please note down, this is very important point. It means here, if the power will be here x, a plus x power n, will get here n plus 1 terms. One more point, this is the first point. In this expression, if we expand a plus x power n, we will be getting here n plus 1 terms. It means here, if x plus 1 power is 10, we will be getting here 10 plus 1, 11 terms. Okay, now second point, what is happening here? You can see here the power of a is 2, here power is 1, here it is 0. That means power of A's power will decrease by 1. Power of A is decreasing by 1 here, 2, 1, 0. Now we can write here power 0. Now what about x? X power is here 0, 0, 1, 2. And x power will be, power of x will increase by 1. Okay, so remember, this is very important point that should be remembered. Power of a will decrease by 1 and power of x will increase by 1. Total number of terms is always n plus 1. Second, and now third point is here, if we see carefully here, it starts with, see here, starts with a power, here you can see it starts with a power 2 and ends with x power 2. Look here and here, if 3 power 3, so, and so it means here x plus a plus x power n will start with a power n, and end starts with starts with and ends with x power n. See here, so at first here power 3, so 3 is there, and at last there is one more point. So the coefficient of terms equidistant from first and last will be same. See here, this is second term, now from last also second term, so coefficient will be same. So the numerical coefficient, we can see a numerical coefficient will be always same. Okay, in this case these are some important points. Now also, now how do we write the formula, or what actually, how can we have the formula for a plus x power n? Just I'm not going to prove it, but I'm simply writing the formula and then I'll be solving this problem. So in this case here, simply a plus x power n, we are just writing here for any positive integer, but it is true for any number. So a plus x power n, so it will be simply as I told you. So right here, c n comma 0 a power n, combination of n and taking r at 0 at a time. So c1, go on n and now 1, so a power n minus 1 x plus c n comma 2, it gives here a power, as I told you, n will be decreasing, so it is n minus 2, x will be increasing, so c n and 3 x power, so first a power n minus 3 x power 3. So remember that, so this is how we are getting, and then so let me write one more term, c n 4 x, a power will be decreasing, so n minus 4 times x power 4. At last here, c n comma n and x power n. This will be our answer, as we discussed before. So this is called binomial theorem. This is binomial theorem. And there is easy way of writing. So just start with c n0. Now write here n0. So n1, n2, n3, n4, and so on. At last there will be n. Now start with a power n, and now goes on decreasing its power. So n minus 1, n minus 2, and then at last there will be 0. Now start, or you can start from last also. So now write at last, write power of x as n, and then go on decreasing, or you can write here the power of x will be increasing in here 0, 1, 2, 3, and so on. So now what is actually general term, you can see here. So to understand general term, see here, actually it is the nth term also. So in first term is how much here, c n0 a power n. So t2, second term is simply here c n1 and a power n minus 1 x power 1. t3, if you see here, c n2 and then a power, see here, first term t1, t2, t3, t4. t3 is how much there, a power n minus 2 x power 2. t4 c n, and then it is here 4 means 3 is there, and a power n minus 3 x power 3. Now general term will be simply, so from this you can see here, if I have to write t, see here 1, here 0, here 2, here 1, here 3, here 2, here 4, here 3. That means tr plus 1 will be cnr. Okay, so c and 1 minus 1, 0, 2 minus 1. Okay, this is our way. So a power, let's see the power of a. In this case, what is happening here? Let's see the second term. 2, then minus 1, 3, then minus 2, 4, then minus 3. So it will be here into a power n minus r. Okay, n minus r. See here, you can now here 4, here 3. Let me see here this 3. So here 3. So r then x power r. and this is called the general term. Okay, this is called the general term. From this we can find tr plus 1 is called the general term. From this we can find any term, fifth term, sixth term, seventh term, and so on. Okay, now let me solve the problem. Hope you understood this. So now we have to expand a plus b whole power 7, and we have to simplify it. So similarly we can solve other problems. So as before, if you remember the formula, it will be very easy for you. So just right here, let me write and explain it for you. So the formula is here. So cn 0 and then a power n. So cn comma 1 a power n minus 1 x plus c n 2 a power n minus 2 x power 2. Similarly, and it will be like this, and so at last c n n and x power n. This is how we write. This is the formula. So now we can easily expand. So right here c n is almost 7 comma 0 a power n means 7. See here 7. Now goes on decreasing the power of a and put increasing power of b. So c 7 1 and then a power 6 into x means here simply it is here b plus c 7 2 a power 5 b power 2. Always remember the sum of the exponents will be always n. 6 plus 1 7, 5 plus 2 7. See here also 7, n minus 1 plus 1 and n minus 2 plus 2. Always the sum of exponents. Note down as sum of exponents is n in each term. Note down, and so it will be easy for you. Now next term will be, as I told you, there will be n plus 1 term is here 7, so 8 term will be there. So now 7 c3 a power 4 b power 3, then 7 c4 a power 3 b power 4, 7 c5 a power 2 b power 5, 7 c6 a power a1 and b power 6 plus 7 c7 a power 0 and b power 7. So let's expand and simplify it. That will be our final answer. So let's see what we are getting here. So we know c7 means it is always 1. c7 comma 0 is 1, so a power 7. So it will be 7, expand this, a power 6 into b plus c7 7 c2 is here simply 7 into 6 by 1 into 2, so it is simply 3, so 21. This is also equals to 7c5. So now it will be here 21 a power 5 b power 2 plus 7c3 is simply here 7 into 6 into 5 by 1 into 2 into 3, so we'll be getting here 35, and it equals also 7c4. Now 7c3, so it is here 7c3 means 35 a power 4 b power 3 plus 7c4 is, as I told you, it is simply here, so 35 a power 3 b power 4 and then plus 7. Now 7c5 means here already given here 21, so 21 a power 2 b power 5. Now 7c6 equals 7c1, so it is simply here 7, so 7 a into b power 6. At last it will be 7c7 equals j. We can write here 1, and also 7c0 equals 1, so it is here simply 1 means this is 1, so it is here b power 7. Now note down. So as I told you, this is our final answer. 1, 2, 3, 4, 5, 6, 7, 8 terms. In each term, the power sum of the exponent is 6 plus 1, 7. And now equity state from this second from first, second from last is again 7 here. Third 1, 2, 3 from third term from last, and third term from first is again here same coefficient, numerical coefficient will be same. This 4 from first, fourth term 1, 2, 3, 4, fourth term from first, and 1, 2, 3, 4, fourth term from last, also numerical coefficient is same. This is our answer for first question. Okay, hope you understood this. Now let me solve number 2. So it for you. Number 2, find the seventh term of this 2x plus y whole power 12. So to find seventh term, first we write here general term. So general term is tr plus 1. Hope you remember that formula. So it is here cnr and a power n minus r x power r. This is your answer. So now let's find what the general term in this case. Tr plus 1 will be c, n is here c, n 12, and r, a is almost 2x power 12 minus r times x is here y and r. So we have to find the seventh term. So we can find here simply t7 means t6 plus 1. Remember, okay, so our r is 6. So c 12 r means 6, and 2x whole power 12 minus 6 into y power 6. So how much is the answer? Let's see here. C 12 6, and then 2x power 6 y power 6. So now you can simplify here. 2 power 6 is here 64, and then you can write here C 12 6, and then by calculation we will get here answer into 2 power 6 into x power 6 into y power 6, and it is here. Find the general term. So it's very simple. X square plus 1 by x whole power 6. So as I told you, general term is here simply tr plus 1, and the formula is ncr a power n minus r times x power r. So we'll get here tr plus 1, that is our general term. N is 6 cr, and a is x power 2, and then n minus r means 6 minus r times x power r. This is in power, so x means 1 by x whole power, r is r. So what will be there? A 6 comma r times x power 12 minus 2r, and then x power we can write here minus r. So that will be getting here c 6r x power 12 minus 3r. This is our general. 4 is find the coefficient of x power 5 in the expansion. X plus 1 by 2x whole power 7. We have to find the coefficient of what? X power 5 in this expansion. So let's first write here general term. So general term is simply, we can write here tr plus 1 is here simply tr plus 1 equals 7 cr and x power 7 minus r and 1 by 2x power r. This is all. So by simplification, what we can write here 7 cr, and this is here x power 7 minus r. What you simplify, and first you simplify for x, so we can write here 2 power r x power minus r. It gives here 7 cr 1 by 2 times 1 by 2 power r, and the x power is here 7 minus 2r. Okay, so it means here we have to find which term. For x power 5, there must be here, for x power 5, the exponent of x in both sides must be same, so equals 5 equals 7 minus 2r. It gives here 2r equals 2, therefore r equals 1. So we can write here, so coefficient of x power 5 will be simply here 7c1 1 by 2, and this will be 7 if you put here 1, so you are getting here, so this is our same, so 7 by 2 is your answer. Okay, so if you have to find the coefficient, so again we use the formula for general term, and from that we'll find the value of r by simplifying for x and equate the exponent of or power of x in both sides. So from that you will get the value of r and then substitute. Thus coefficient means write the numerical values, there shouldn't be x. Now question number 5. Let's see here question number 5. Question number 5 is here. Number 5. So find the independent term, or maybe the free of x, the term which is free of x in the expansion of x squared 1 by x power 12. So always for this also we'll find the general term. What is the general term? We can write here general term is tr plus 1. Remember that. So it is here tr plus 1 and it is here simply x. So let me write here it is 12cr and a is here, so this power n minus r 2 12 minus r times 1 by x power r. So let's simplify this 12cr times x power, it is here 24 minus 2r x power minus r, so it gives here 12cr times x to the power 24 minus 3r, 4 term independent or free of x. It should be here x power 0, so power of x should be 0, power of x should be power of x equals 0, that is, or we can write here 24 minus 3r equals 0, then 4r equals 8, that is tr will be here 8 plus 1, that is t9 is the term, ninth term, that is ninth term is independent term, ninth term. And now what is the answer for that? Let's write here t9 equals how much? T9, let's put here 12, value of r is 8, you can see here 8, see 8. Now if you put here it will be 0, so simply it is here 12 c 4 and 12 into 11 into 10. So let me simplify here, so we can write here 12c4 means 12 into 11 into, let me simplify, 10 into 9 by, or you can simplify by yourself also, 1 into 2 into 3 into 4, so 4 3s are 12, let's cancel this. Now 2 is here 2, 5 is 10, so it will be here 45 into 11, answer will be 4 9 and 5. This is your answer. Question number 6 is here. Now question number 6, find the middle term of we will find the middle term, so x plus 1 by x whole power 18. First question number A. Okay, so before expanding, so we know that suppose here 2 4 6 8, there are 4 terms, so middle terms, these are the middle terms. There will be middle terms, two middle terms, n equals 4. Now if we see here 2 4 6 8 9, so here n equals how much? How many terms are there? 1 2 3 4 5, so only one term will be there, one middle term. This is the middle term equals here 6, only one. only 1. So it means here you have to remember these two middle terms. Okay, 2. So it means here if the number of term is even, there will be 2. So you can see here 2 middle terms. If number of term is odd, there will be only 1 middle term. This is how we'll solve the problem. Okay, so let's see the first one, 6a. So number of terms will be here. Number of terms in the expansion of x plus 1 by x, number of terms will be 18 plus 1, it is 19, which is odd. So only one middle term will be there. Term will be there. There will be only one middle term. Now what is the how to find the middle term? So simply here, so look here again, I can remind you. So 1 2 4 6 8. So if we see here, this is first, second and third. So let me take example of odd term. So here third term, so n equals, so t2 is middle term, isn't it? Middle term, it means here what? So second term, isn't it? Second term. So second term means we can write here, so n equals 3. So 3 plus 1 by 2, it is here second term. This is how we can get here 3 plus 1. So n plus, in case of odd numbers, so this is how we can find that. So middle term equals to, middle term will be simply here t 19 plus 1 by 2. So it is here t 19 plus 1, 20 by 10. So it is here simply t 9 plus 1. So according to this formula, what is the middle term? So t 19 is t 9 means here 18 c r x power 18 minus r, and then it will be simply here, you have to find the middle term. So it will be sorry, it is a 9 means r means here 9, 18 c 9, and it is here 9 into 1 by x power 9. So how much we are getting here? 18 factorial by 9 factorial times 9 factorial into x power 9 by x power 9. These two cancel, so answer will be 18 factorial by 9 factorial and 9 factorial. This is our answer in this case. This is our middle term. Okay, let's move for second question, number B. So what will be our middle term if we expand? Question number B here, if we expand 2x plus 1 by x whole power 17. So as before, let's find here number of terms. Number of terms. What is our number of terms? 17 plus 1, 18, which is even. So there will be two middle terms. It's not difficult, so you can take here 3, 6, 9, and then so write here any term here. So 12, so 15 and 18. So you can see here 1, 2, 3, 4, 5, 6. 6 are there, means always middle term will be here. So 6 means in middle there are two terms. So okay, you can see here 4 terms. If you take here 1, 2, 3, 4, so 2 will be in the middle. If you take only 3, then only 1 will be in the middle. Okay, this is how we can. So now how to find the middle terms then? Okay, so first middle term. So first middle term will be simply here 18. So simply in this case it will formalize here 18 by 2. It is here t9, and that is t8 plus 1. So simply the formula, according to this formula, 17c8 times 2x power simply n minus r means here it is 9, and then 1 by x power will be there as here. So if you simplify it will be 8. So how much we are getting here, we have to expand this, so you expand and write by yourself. So say 8 into 2 power 9, and then I think here 1 will be cancelled, will be x. This is your answer. You can expand and write by yourself. So next will be second middle term, will be second middle term will be simply here. So 9 means t 10, thus simply plus 1, t 9 plus 1, that will be your middle term. Okay, so next middle term. So in this case it will be here 17, just direct use formula, r is 9, so it is here 9 x power 2x power 9 20, 17 minus 9 is 8, and then so 1 by x power, it will be simply 9. Question number 7, and it is here. So that the middle term of 1 plus x power 2n and x minus 1 by x power 2n are 1 into 3 into 5 in dot 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 into 2n minus 1 into x power n into 2 power n whole divide n factorial. Okay, so first number we have to show the middle term is, in short I'm writing here, middle term equals 1 into 3 into 5 into dot 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 2n minus 1 x power n, and then 2 power n, and the whole divide x, it is here, whole divide n factorial. This is what we are going to prove, middle term. So solution will be here, solution. So first see the given binomial expansion is 1 plus x whole power 2 plus 2n, 1 plus x power 2n. Now so number of terms will be, number of terms equals here 2n plus 1, and it is odd, so middle, there will be only one middle term, and it will be simply t 2n plus 1 plus 1 by 2, that is simply n plus 1 term. So tn plus 1, that means n plus 1 term. So we can write here, and formula for this is, in this case, 2n c n and 1, so n x power n will be there. This is just I'm using formula t r plus 1 equals, what is the general term, n c r, and then a power n minus r x power r. So in this case a is 1, x is x, so 1 means we don't have to write this term because power of 1 will be any number, finite number will be 1, so just I'm skipping that. Now if we simplify, we'll have the answer. Let's see here. So what we are getting here, if we simplify, so factorial formula 2n factorial n, and then 2n minus n factorial, then n factorial times x power n. Let's simplify this, so we can write here 2n factorial by n factorial and times x power n. So now look here, x power n is here, this is what we need. We have got x power n, also n factorial we have got. So now remaining we have to bring. So what we can do here, so for 2n factorial, it means say here it is 5 factorial, means what is the 5 factorial? 1 into 2 into 3 into 4 into 5. Similarly 6 factorial means what? 6 means 1 into 2 into 3 into 4 into 5 into 6. That means continued multiple from 1 to, if it is 6 factorial then 6, 5 factorial then 5. Continued multiple from 1 to n, that is n factorial. So now this is what I'm going to use, so that we'll have the answer for 2n factorial, 1 into 2 into 3 into 4 into 5 into 6 dot dot dot, at last it will be 2n minus 1, and then 2n, then x power n, and n factorial, because this is what we need. Now as it is, this is n factorial. What we can do here, look, we need here 1, 3, 5 and 2n minus 1, that means all the odd numbers. So right here 1, 3, 5, and then 2n minus 1. So it will be here simply 1 into 3 into 5 and dot 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 2n minus 1. Now the remaining is here. See here, 2, 4, 6 and 2n. That means all the odd numbers. 2, 4, 6 dot 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 odd number. And then divide n factorial x power n by n factorial. This is what we have to. So now actually this also we have got now this button. Now we need to just balance this and 2 into 4 into 6 into 6. So what we can do here, from this 2 into 4 into 6 into 2n, we can take 2 common, so that we'll be getting here, let me write here, so that we'll be getting, here empty, we are getting here middle term. So 1 into 3 into 5 into dot 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 2n minus 1, then x power n by n factorial we have. Now remaining is here. So if we take 2 common, so 1 2 will get here. See here, just I'm taking 1 into 2. For this we can write here 2 into 2. For this we can write here 2 into 3, and then last dot dot dot, this can be written as here 2 into n. If I take 2 common, so I'll get here 1 2 3. From 3 terms we are getting here 3 terms, so there are n terms, so we'll be getting here 2 power n, 2 from each, and then the remaining will be 1 into 2 into 3 into dot 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 n by n factorial, and this is nothing but n factorial. So 1 into 3 into 5 dot 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 2n minus 1 x power n by n factorial into, it is also here 2n, and this is simply 1 into 2 into 3 into 4 dot dot n, means it is here n factorial by n factorial. This is cancelled, and this is what we need. Look here. So 1 into 3 into 5 into dot 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 2n minus 1 into x power n into 2 power n by n factorial. This is the result. Okay, for first part 7a. We have proved that the middle term of expansion, if we expand 1 plus x power 2n, we'll get this as middle term. This is what we have to prove. Now this is what we have to prove. So we have already got the answer. Let's move to question number 2 or second. Similarly, in this case also, the question number B is 7b. We talk about 7b, so it is here. Middle term is 1 into 3 into 5 minus 2 power n and by n factorial, same thing. So as before, we can start, and then we have the other solution. The expansion is given here, x minus 1 by x whole power 2n. So number of terms will be, we can write here, it is n plus 1, that means 2n plus 1. This is again odd, so we'll be getting here odd. So there will be only one middle term, and that middle term equals mt inside, we can write here. So t 2n plus 1 by 2. This is here formula, just simply middle term equals n plus 1 by 2th term. If we have n terms, so middle term will be n plus 1 by 2 if n is odd. Okay, so this is what using, this is the formula. So it will be simply here t n plus 1, 2 will be cancelled, so we'll get here n plus 1. Now let's expand this, and then we have the answer. So if we expand, middle term equals, so by general term formula we can write here 2n n and then x power n. So it, in this case, 2n n, so NCR formula, this is what I'm going to use. R plus 1 equals a NCR a power n minus r x power r. So in this case a is what, x, so x power n minus 2n minus n, and then minus 1 by x power will be n. because in this case r equals n. Okay, so if we simplify this, so it will be here 2n factorial by 2n minus n factorial to n factorial, and this is here x power n into minus 1 power n by x power n. So these two cancel. Now let's expand this so that it's before we can expand this one into 2 into 3 into 4 into 5 into 6 to dot 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 2n minus 1 into 2n and then minus 1 power n. Okay, so we'll get here n factorial and n factorial. So if we simplify further, we'll be getting here, let me rub this and solve it for you. So you can do by yourself also. If you want to try, please you pause this video and try by yourself. So what we are getting here, mt equals simply as before, we can write this as 1 into 3 into 5 dot 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 2n minus 1. Just take here odd number, odd number, odd number. So remaining will be the even numbers, so 2, 4, 6, 8 dot 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 2n and by n factorial and minus 1 power n. So 1 into 3 into 5 into dot 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 2n minus 1. This is our first part, and from this we can take 2 common from each. So 1, 2, 3, 4 n will get here 2 power n, and then 1 into 2 into 3 to 4 into dot 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 n, which gives n factorial. So n factorial minus 1 power n. So if we simplify further, we'll be getting answer as here 1 into 3 into 5 dot dot 2n minus 1. So 2n and n, we can write here 2 power minus 2 power n, because minus 1 is here and 2 is here, power is same, so we can combine them. This is n factorial by n factorial and n factorial. These two cancel. We have the answer 1 into 3 into 5 dot 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 2n minus 1 times minus 2 power n by n factorial. This is what we have talked. We can see here 135 and times 2n minus 1 minus 2 power n by n factorial. This is what we need, and we have solved this. We have the correct answer. So my dear students, don't forget, you need to practice a number of times. If you practice, then I'm sure you'll be getting the answer within very short time. We'll move to question number 8. Question number 8 is here. Now question number 8, 7 solved. In the expansion of 1 plus x power 21, the coefficient of 2r plus 1, coefficient of, this is the question, coefficient of 2r plus 1th term equals, it is given here coefficient of 3r plus 2th term. This is what we are given. Okay, now if so, we have to find the value of r. If so, we need to find r, the value of r. So simply, so before solving this, let me explain one thing. We have to find the coefficient of 2r plus 1, coefficient of. Okay, so how do we write the coefficient of this? So one way is there, let's write the general term, and from that we can write the coefficient of 2r plus 1, but it will take more time. So I'll teach you a very shortcut way, an easy way. How can we solve this? So similarly, we have to write the coefficient of 3r plus 2th term. So how do we get, actually let me explain it. Here we know that the general term is here ncr a power n minus r and then x power r, for a plus x power n, isn't it? So now but here a equals 1, so we can write here general term will be a tr plus 1 will be simply ncr and then x power r. So now what is the coefficient of tr plus 1? So coefficient of tr plus 1 is simply ncr. Remember, if r plus 1 is here, so simply it will be ncr. That means the value of r will decrease by 1. This is the coefficient of tr plus 1 in the expansion of 1 plus x whole power 21 or 1, whatever here. So similarly, we'll be solving this problem. Now you can write the coefficient easily. Okay, so let's now solve the problem. Use this concept. So coefficient of, we can write here, coefficient of 2r plus 1 will be t, 2r plus 1 will be simply n means 21, n c r will be 2r. Remember here. So again similarly we can write here coefficient of t 3r plus 2, it can be written as here t 3r plus 1 plus 1. Okay, so simply it will be 21c, and what will be the value of r? 3r plus 1. Okay, so now by equation we are given that these two are equal. By equation we can write here, 21cr equals 21c 3r plus 1. And now we have one formula, that means ncr equals ncr dash. So in that case r plus r dash equals n, or r equals r dash. So now in this case, look here. So first, if we take here r equals 3r plus 1, we'll get here 2r equals minus 1, which is not possible because n and r belongs to set of natural numbers. So we'll use the another condition, this one, r plus r dash equals n. So what we will get from this if we use this result? So in this case we are not going to use this one, second one. So r plus 3r plus 1 equals 21, which gives or equals 20. Okay, so what do we get here? Therefore r equals 5. This is our answer. So actually sorry, here 2r, so I'm missing here 2r, so it is here 2r, so it will be simply 5r, so you will get here n r equals 4. So remember here what, just say the coefficient of t 2r plus 1 will be simply n and r, the value of r will decrease by 1, so it is here 2r plus 1 means 2r plus 1, 3r plus 2 means 3r plus 1 will be there, and these two will be equal by given condition. So we can use this result already I have proved. So if you want to see the proof for this, you can go to previous video and then you can watch and understand also. So let me solve another question. This is A, 8a. So now let's move to B, 8b, and this. Okay, so that is our answer. So understood, hope you understood what I did. Actually what I actually did is, to solve the problem, actually I calculated the coefficient of t 2r plus 1, that means coefficient of 2r plus 1 term, and then coefficient of 3r plus 2 term, and then I equated. In that case I have used one result of combination, that means ncr equals ncr dash. Then in that case we can use either r equals r dash or r plus r dash equals n, then we'll get the answer. This is how we solve the problem. So now let's move to question number 8b. We have to again one more result we have to prove. So in this case, question number b, if you see here, solve the question number b. In the expansion of 1 plus x power 2n plus 1, the coefficient of x power r, we are given here coefficient of x power r equals coefficient of x to the power r plus 1. In that case we have to find what is the value of r. In this case we have to find the value of r. So now again, as before, let me first explain. Before solving this, let me explain how do we write the coefficient of x power r. So as we know that dr plus 1 equals ncr, and then a power n minus r, x power n minus x power r, simply x power r. So it is for a power x plus n, a power x whole power n, but here a is given, simply a equals 1, so we can write here dr plus 1 will be ncr, this term will be eliminated, so that we will get simply for this 3x power r. So what do you mean? Coefficient of, watch carefully, okay? So coefficient of x power r, coefficient of x power r will be simply ncr. Not the point. The point that should be noted is, if here power is r, so it will be the value of r the same. That means the power or exponent of r will be the value of r. This is what we have to know, or this is what we have to remember, so that we can solve the problem easily. So what will be the coefficient? So use this concept, coefficient of x power r in 1 plus x power 2n plus 1 will be simply, n is 2n plus 1, okay, and then c, r means r, okay. So simply we can write here, let's write the coefficient of, again, coefficient of x power r plus 1 in expansion of 1 plus x power 2n plus 1 will be simply 2n plus 1. See, the value of r will decrease, so whatever is here, it should be the value of r plus 1. See here, r, so r, this r and this are matching, this must match with this one, okay. So now by question, we are given these two are equal, so coefficients are equal, means we can write here c 2n plus 1 and r equals c 2n plus 1 and r plus 1. So as before, we can use the result of combination, that means r plus 1 equals 2n plus 1. So it will give here, or 2r equals 1 and 1 plus 2n. It means here the value of r is equal to n. In this case, the value of r will be same as the value of n. Okay, n and r will be same in this case. Okay, let's move to, this is the solution. Let's move to question number 9. The question for us, let's solve. So my dear students, hope you are getting this, and if you have any confusion, and then please feel good to share with me. I'm always with you all to support. Okay, I'm always ready to support you all. So let's move to question number 9. Question number 9 is here. So the question is, so that the coefficient of middle term of 1 plus x power raised to 2n is equal to sum of the coefficients of two middle terms of 1 plus x power raised to 2n minus 1. So that means let's find the middle term of this. The question is coefficient of middle term of 1 plus x whole power 2n equals sum of coefficients of, this is what, coefficients of middle terms of 1 plus x power 2n minus 1. Okay, so first what should we do? Let's find the coefficient of middle term of this, then let's find the coefficient of middle term of this, and then prove this result. So first for this, so for 1 plus x power 2n, let's find first the coefficient of middle term of this. What is the middle term in this case? So number of terms will be 2n plus 1 equals, which is, we can write here odd, so then only one middle term will be there, so middle term will be simply 2n c n, and r will be this 2nl plus r, and then we have to find the value of ncr middle term. Okay, let me write here middle term first. So to get the middle term, this middle term equals mt will be t 2n plus 1 by 2, that means here tn plus 1. So simply we can write here 2n and n, and then x power n. So coefficient will be what? What is the coefficient? Coefficient of middle term will be 2n cn, that is 2n 5. Okay, this is the middle term in this case. Now let's move to this second one. So here number of terms will be, in this case, number of terms we have almost 2n minus 1 plus 1, that equals 2n, and which is even, so there will be two middle terms. So middle term first one will be simply t n by 2. Okay, so n by 2 will be there. So what we can do here in this case, two number of middle terms here, 2n minus 1, so number of terms is this. So 2n by 2, it is here simply t n, and this it means here t n plus n minus 1 plus 1 we can write here. So we can write here n, and then middle term will be nc, r means n minus 1, and then x power r means x power n minus 1. So coefficient will be, first coefficient will be coefficient of mt, first middle term, so will be here simply 2nc n minus 1. Now let's find the second middle term, and then so mt2, second middle term will be how much? T just plus 1, n plus 1. So in this case, so the middle term will be simply 2n nc n, and then x power n. So coefficient will be coefficient of nt, second middle term will be simply almost 2nc n. Now let's see what we have to prove. Now let me write this and explain it. So we have to prove that first one is, that means, now look here, sum of these coefficients, this plus this, how much we get here? 2ncn minus 1 plus 2ncn, this can be written as here 2n minus 1 plus c 2n. So now I have given one result, n c n r minus 1 plus c. Hope you remember this result, r is equal to n plus 1 and r. This is the result. So from this result, what we can write here, c n c r n, so n will be increased by 1, and so that will be getting answer. So what is our answer in this case? Sorry, I have done something mistake here. So it is in this case 2n plus 1, right? So power is here 2n here minus, so it will be here minus 1, minus 1, and minus 1, so minus 1. So it is here minus 1, so minus 1 and minus 1. Minus 1 should be here. So that will be getting answer as C 2n minus 1 plus 1 and the greater one n, so which is equal to C 2n comma n, and which is the coefficient of, and which is same as the coefficient of middle term of the first expression. Hope you understood this, and if you have any confusion, please you share with me so that I can help you. I'm always there to support you all. My dear students, mathematics is not difficult. It is not so hard. It is not tough. And what we can do here, it is all about our way of learning. It is all about the way of teaching. So, and remember one thing, so the shortcut or the trick for mathematics is you practice a number of times, you give more times, you do the mathematics, then you will understand, and then you can excel by practicing it. Thank you so much. God bless you. Lesson number 10. So if the three consecutive coefficients in the expansion of 1 plus x power n b, it is given here in the expansion of 1 plus x power n, three coefficients are given to be here, 165, 330 and 462. We need to find the value of n. So let t r plus 1, t r plus 2, t r plus 3 be three consecutive terms of 1 plus x power n. Then we can write here t r plus 1 equals ncr x power r t r plus 2 will be ncr x power r plus 1 will be here, x power r plus 1, tr plus 3 will be ncr plus 2 x power r plus 2. Now we are given here, now we can write here by given question ncr equals 300, 165, it will be equation 1. ncr plus 1 equals how much? 330, it is given here. ncr plus 2 equals how much? It is given 462, 2 and 3. Now let's divide 2 by 1. If we divide equation 2 by 1, we'll get this as ncr plus 1 by ncr equals here 330 by 65 is equals 2. And if we divide this, we get here n factorial by n minus r minus 1 factorial times r plus 1 factorial, okay, we'll divide, it will be n factorial n minus r factorial and then r factorial equals to n and n cancel, and then if we simplify further, this r will go in numerator, so r factorial, and then if we simplify this n minus r times n minus r minus 1 factorial we can write, and then denominator is n minus r minus 1 factorial, r plus 1 factorial can be written as r plus 1, and then r factorial equals 2. So this cancel and this cancel, so what we can write here by simplification, we can write here, let me write here, from this we'll get here n minus r by r plus 1 equals 2, which gives here n minus r equals 2r plus 2. Therefore, the value of, you can write here, or n equals 3r plus 2, so that we can write here r equals, as we have to find the value of n, this one n minus 2 by 3. It would be equation 4. Now let me write all the results, and then if we divide here again, if we divide 3 by equation 2, we'll be getting answer as ncr plus 2 by ncr plus 1 equals here 462 by 330. So times, if we divide this by 11, we'll get here 30. If we divide it will be 11 by 462, then we'll be getting 462 by 11 will get here 42, and 6 5 and 6 7. So what we can write here, so let's simplify further to get the answer. Final answer will be here as, now we can write, or it is going to be n factorial by n minus r minus 2 factorial, then r plus 2 factorial whole divide, again n factorial, then n minus r minus 1 factorial, r plus 1 factorial equal 7 by 5, isn't it? So let's simplify, and cancel, so this will go up, so r plus 1 factorial, now this will go up, so it can be written as n minus r minus 1 times n minus r minus 2 factorial equals here 7 by 5, and then denominator will be n minus r minus 2 factorial, then times r plus 2 into r plus 1 factorial, so that we can cancel from numerator and denominator, and we'll be getting answer as here 5n minus 5r minus 5 equals 7r plus 14. So it will be simply 5n equals here 12r plus 19, or we can write here 5n equals 12 into n minus 2 by 3 plus 19. So 4 times it will give here 5n equals 8n minus 8 plus 19. And if we simplify this, so it will be 4 to the 4n. So it will be here, therefore n equals 19 minus 8 is 11. This is our final answer. 11 is your final answer. Okay, now let's solve to next one, question number 11. 11 is the answer for first question number 10. We have solved this. Now move to 11 number, question number 11. Here the question is 11 number. We are given here if 4 consecutive coefficients in the expansion of this as before, let's suppose here, let here t r plus 1, t r plus 2, t r plus 3, t r plus 4 be 4 consecutive terms of 1 plus x power n, then tr plus 1 will be ncr x power r, tr plus 2 will be ncr plus 1 x power plus 1, tr plus 3 will be ncr plus 2 x power plus 2, tr plus 4 will be ncr plus 3 x power r plus 3. Okay, by equation. Now we can write here, we are given these 4 consecutive coefficients are given to be a1 equals ncr, a2 equals ncr plus 1, a3 equals ncr plus 2, a4 equals ncr plus 3. This is what we are given. Now to solve this, this is what we have to prove. So let's find the value of a1 plus a2. a1 plus a2. What will be the value of a1 plus a2? ncr plus ncr plus 1. So we know what formula for this. So it is simply n plus 1 c r plus 1. Similarly, you write here a2 plus a3 will be a2 plus 3, 2 plus 3, then ncr plus 1 plus ncr plus 2. So in this case, n plus 1 cr plus 2 will be there. So a3 plus a4 will be how much? S3 plus a4 will be simply here see a 1 then 1 and here 2 then 2, so 3 then 3 will be there, n plus 1 and r plus 3 will be here. Now simplify this further to get the answer. So now what we are getting here, let's find the value of, let me write here a1 plus a2 is how much? N plus 1 cr plus 1, a2 plus a3 is how much here? We have to use this result, so I'm writing here n plus 1 r plus 2, a3 plus 4 equals how much? N plus 1 and r plus 3. Okay, these are the results. So I'll draw this. So how did I got this result? So you may have confusion then. So remember here one formula is c n r plus c n. Already I proved these results, c n and r minus 1. For this always formula is n plus 1, c n plus 1, and among these two greater will be there. So this is how we have got this result. Okay, so you can see this result in my previous video. Now we need to find the a1 by a1 plus a2. So let's see what we are getting here. a1 by a1 plus a2. So a1 is ncr by a1 plus a2 is n plus 1 r plus 1. So what we are getting, if we simplify this, n factorial by n minus r factorial, isn't it? So, and this n plus 1 factorial by n plus 1 factorial times n factorial minus then n by n plus 1 minus r minus 1 factorial r plus 1 factorial. So if we simplify this, we'll be getting answer as n factorial by n minus r. So this is n minus r, n minus r, remaining n minus r cancelled. So we have answer as this is remaining is here r factorial and then whole divide. Again here we have n plus 1 factorial means n plus 1 times n factorial whole divide r plus 1 into r factorial. So we can cancel this and this factorial, so we'll get answer as r plus 1 by n plus 1. It means here one more result we have. Now a1 by a1 plus a2, it's simply here r plus 1 by n plus 1. Now we can write here a1, so r plus 1, a2, then r plus 2 will be there, a3, then r plus 3 will be there. So let me show one more result and then I'll write the third one as thus by similar process by induction we can write here. So let's see here what is the value of a3 by or a2 by a2 plus a3. So what do we get answer for this? a2 means here a2 is how much here n cr plus 1, isn't it? So and a2 plus a3 is here n plus 1 c r plus 2. So let's use formula for this. So n factorial by n minus r minus 1 factorial and then r plus 1 factorial whole divide n plus 1 factorial divide n plus 1 minus r minus 2 factorial and then r plus 2 factorial. Let's see here n minus r and then this will be minus 1, so these two cancel. So again as before, if we simplify we'll be getting equals this is n factorial by r plus 1 factorial, then we can write here, so it will come in numerator, so r plus 2 into r plus 1 factorial and then so what will be the denominator will be n plus 1 factorial means n plus 1 into n factorial. This n cancel, so r plus 1 cancel. So what we are getting here r plus 2 by n plus 1. So one more result we have. So now we'll write direct. So now best we can write here a2 by a2 plus a3 is r plus 2 by n plus 1. So note down, in both result we have denominator as n plus 1, but that means in denominator there is no change. So similarly we can write here, similarly if you proceed we can write here a3 by a3 plus a4 will be obviously r plus 3, because see here 1 then plus 1, 2 then plus 2, 3 then plus 3 will be there in each n plus 1 n plus 1, so here also will be n plus 1. Now we have the result, so let's see here LHS a1 by a1 plus a2 plus a3 by a3 plus a4, so it will be simply a1 is how much r plus 1 by n plus 1, a3 is r plus 3 by n plus 1, so it gives here denominator system, so r plus 1 plus r plus 3 is divided by n plus 1, so it gives here 2r plus 4 by n plus 1 or 2 common, so r plus 2 by n plus 1, and which is nothing but 2 times a2 by, you can see here a2 by a2 plus a3 equals RHS. Okay, hope you understood this. Hope you have. Here it is. So we have to prove this to prove this c1 minus 2c2 plus 3c3 and then minus dot 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 plus n minus 1 power n minus 1 equals times cn equals 0. This is the first part. We are given here 1 plus x power n equals this. So remember, in this case we'll be using this result. So c0 plus c1 plus c2 plus dot 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 up to cn will be always 2 power. Sometimes we have to use this result. This we can get from here 1 plus, we are given here 1 plus x power n equals c0 plus c1 x plus c2 x square plus dot 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 cn x power n. So if you put here x equals, we'll be getting here 2 power n equals c0 c1 c2 and dot 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 cn. This is what we are going to use also. So directly I'll be using this. So for first part, look here, we are not given here c0. So to remove c0, we'll differentiate on both sides, because derivative of constant is always constant is 0. This is this is what I'm going to use. Constant of derivative of constant is 0. So this is what I'm going to do. So I'll take derivative on both sides in this given equation. And then also how this idea came. So how to get this idea. So you can see here the power is n minus 1. So how do you get power n minus 1? So by taking derivative. Okay, so this is what I'm going to use. I'll be taking derivative. So you can write here differentiating both sides. We'll be getting here differentiating both sides means here n and then 1 plus x power n minus 1 equals, simply here this will be 0, c1 plus 2 c2, and then it will be here 3 c2 x, because the derivative of x square is derivative of let me write here differentiating derivative of x is 1, derivative of x is x, and so plus here, then derivative of here it is 3 c3 x cube, so it will be 3 c3 x square, and then dot 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 plus at last it will be here n cn x power n minus 1. So if you put here x equals minus 1, because see here in right hand side we have 0, so by putting x equals minus 1 will be 0. So also you can see here this term is negative, so how will we get this term negative? Putting x equals minus 1, so it will be, this term will be 0 equals c1, and minus 1 means here minus 2 c2, then plus the square is here, so 3 c3 after this, so it will be here minus and dot 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 plus. So look here, n cn minus 1 power n minus 1. This is what we need. So therefore we can write here c1 minus 2 c2 plus c3 minus dot dot dot, just add in this minus 1 power n minus 1 into ncn equals 0. ncn, you can see here, ncn equals 0. This is proof for second part. This is proof for first one. So let me prove the second one, question number B. How can we solve this? This is the first one, already we have proved. So now for second B, to prove this, c0 c0 plus 2 c1 plus 3 c2 plus dot 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 n plus 1 cn equals, you have to prove n plus 2 times 2 power n minus 1. This is what we have to prove. So now let's write here LHS. For LHS we can write here c0 plus, like this 1 plus 1 c1 plus c1, and then c2 plus 2 c2 plus dot dot dot, then just open this n cn plus cn. So now what we get as, let's arrange this and this, the last one. So c0 plus c1 plus c2 dot 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 cn, and then remaining will be here plus c1 plus 2c2 plus dot 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 and n cn. So as I told you, So directly we can get the value of this. So just put here x equals 1 in given. So it is 2 power n plus. Now how to get this? C1 plus 2 C2 plus. So what do we get here? In this case also as before there is no C0. So we differentiate this. For this, let's write as it is C1 plus 2 C2 plus dot 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 to get the value of this. Just up to here. I leave up to here and then I'll move. So let's use the given 1 plus x whole for n is given c0 plus c1x plus c2x square and dot 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 it is given cn x power n. So I can differentiate both sides with respect to remove this c0 with respect to differentiating both sides. What do we get here? So it is simply n 1 plus x power n minus 1 power rule. So it is here c1 plus 2 c2 x plus dot 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 n cn x power n minus 1. Now what we need here? We need here this 2c2. See here x. So put here x equals 1. We get here of n into 1 plus n 2 power n minus 1 equals c1 plus 2c2 plus dot 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 n cn. So now from start we can have here now LHS equals, we can write 2 power n plus this is n 2 power n minus 1. Now we have to prove this one. So let's write here 2 into 2 power n minus 1 plus n into 2 power n minus 1. So what is common? N plus 2. If you take common, you will get here 2 power n minus 1. This is RHS. You can see here n plus 2, 2 power n minus 1. This is the result. So question number C. Let's move to question number C. Similarly, we can proceed and get the answer. So let's see question number C. Number C is here. It is C0 plus C3 C1 plus 5 C2 dot 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 plus 2n plus 1 and then Cn and then RHS. It is LHS. Okay, so let's first you simplify this. LHS equals C0 plus C1 plus 2C1 plus C2 plus 4C2 and then dot 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 and it is here 2n Cn plus Cn. So let's combine this 1 and this 2 then 3 and then 4 like this. So C0 plus C1 plus C2 plus dot 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 Cn and then the remaining will give where. For remaining we can write here 2Cn plus 4C2 dot 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 plus 2n Cn. So for this we have the result. We can write here 2 power n. From this to all we can take 2 common. So C1 plus 2 C2 plus dot 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 n Cn. And I think we have already used formula for this web. So similarly for this again let's use let B star. So we have given here 1 plus x power n equals C0 plus C1x plus C2x square plus dot 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 Cn x power n. So we don't need x C0, so we'll differentiate both sides with respect to x. Differentiating both sides we'll be getting as n 1 plus x power n minus 1 equals C1 plus 2C2 and dot dot n Cn x power n minus 1. Let's put here x equals 1, so that we'll be getting here n into 2 power n minus 1 equals C1 plus 2C2 plus n Cn. So now from start, again from start we'll get here LHS equals 2 power n plus 2 times n into 2 power n minus 1. So it gives how much? This is what we need here. So 2 power n plus second here, this will give here n into 2 power n, and if we take 2 power n common, so we'll get here n times this is RHS, isn't it? So this is what we need. Question number C. Let's move to D number D. Hope you are getting this, and if you practice, I'm sure you'll be solving like this within just lesser time. You can solve if you have lots of practices. So question number D. Let's see, D number. For D, we have to prove C1 by C0 plus 2 times C2 by C1 plus 3 times C3 by C2 plus NCN by Cn minus 1 equals, we have to prove n into n plus 1 by 2. Okay, this is what we have to prove. Let's see here, for this we need to find value of C1 by C0. Actually, what is the meaning? C1 means it is here Cn comma 1 by simply Cn comma 0. So what is the formula? Formula of this is here Cn means I've already given formula for this here n, and then formula for this is here simply 1. So it is simply 1. C2 shortcut method is already given for this. C2 by C1 means what? N into n minus 1 and 2 steps. So for this 1 into 2 whole divide C1 is n simply, so n by 1. So this n cancelled, so we have here n minus 1 by, so this is 1 term, so okay, so n minus 1 by n minus 1 by 2. So it means that 2C2 by C1 will be n minus 1 simply. Okay, let's see what is the value of 3 times C3 by C2. So for this I have already given formula, so shortcut method is n into n minus 1 and then n minus 2, isn't it? 3 steps, then 1 into 2 into 3. For these 2 steps, n into n minus 1 by 1 into 2. So 1 into 2 cancel, 3 and 3 cancel, n minus cancel. So we are getting here n minus 2. So it means here we have now look. So if you substitute this value, LHS becomes here, this is n plus n minus 1 plus n minus 2 and dot. So let me show you what is the value of this NCN, n times Cn by Cn minus 1. So actually the value of this is Cn by Cn minus 1. So we know by property also this is 1, and then Cn can be written as here C again here Cn means here, so we can write here n and 1. So NCR formula, and it is again here n by n. Okay, so because NCR equals NCn minus R. So if you use this formula, so C for this, I'm just explaining. So C will be there n, and n minus n plus 1 will be there, and it gives here C n and 1. Cn1 means simply 1. You know that one. So n by 1, n by 1 equals n. So now we have this equals 1. Isn't it? So at last there will be 1. So actually what is happening here? So if you arrange the term, we are getting here, this can be written as. So from n we are decreasing by 1 and coming to 1. That means it is being decreased. So it will write from first. So it will be, I think, decreasing 2 plus 3 plus 2 plus 1 n. So 1 plus 2 plus 3 plus plus n minus 2 plus n minus 1 plus n, and it is nothing but sum of what? Sum of n natural numbers, and which is just n into n plus 1 by 2. This is our formula. This is the RHS. We have the answer. Now move to E. Question number E. So let's see how do we solve question number E. Let me explain it for you. Question number E. For E, look here. Cn C0 into Cn plus C1 into Cn minus 1 dot 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 Cn times C0. We have to prove that 2n factorial by n factorial. This you have to prove 2n factorial by n factorial and n factorial. Okay, so this is what you have to prove. For this, look here. If you see question number 1, E, F, and G, these are of different type. These are of typical type. In this case, in these three cases, we'll be using different technique to solve this. So how to remember this? In each case, we can see here. In each term, there is n. Remember trick to remember this method. There is n means no change. No change. You don't change. That means 1 plus x power n and 1 plus x power n will be there. But in case of this f, there is constant. Okay, so there will be change. It means here 1 plus x will write here one time. Second time will write here x plus 1 power n. Okay, remember this step. This is how I remember and I solve the problem. So if you remember in this way, you can easily solve the problem within seconds. Now let's solve this. Now in this case, what we do right here, we have 1 plus x power what n equals already given here c0 plus c1 x plus c2 x square plus dot 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 cn x power n. I can write here 1 plus x power n. So what we can do here, if we write here, as I told here, n means no change, we don't change here. So now what we can do, so look here, if I write from last, what we can write here from last, right there. So simply we'll be getting answer here c1. So it will be here n means there will be no change, means it's just there. Simply from last, if you write here, right from last, so cn x power n plus c1, so cn minus 1 x power n, before this will be here n minus 1, and then cn minus 2 x power n minus 2, from last I'm writing dot 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 dot, it will be here, so last c1x c2x square plus c1x plus c0, isn't it? So now if you multiply both, multiplying both, we'll get here, actually it is 1 plus x power 2n, isn't it? Now multiply in such a way that say just this into this c0 c and x power n, multiply these two, so c1 cn minus 1 x power n, you can check there n power, again cn minus 2 c2 x power n dot 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 dot, at last you will be getting here, I'm not multiplying all the terms, just the terms which are needed. So c0, so to be there at last, so you can see here, this is what we need here in number A, c n and c0, isn't it? Plus a number of terms will be there, we don't need that. So now we can write like this, c0 x cn cn plus c1 cn minus 1 plus c2 and cn minus 2 dot 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 dot, plus at last it is here cn c0 times x power n and plus dot dot dot, a number of terms are there. Now this is an inequality, that means this is an identity, and if we equating now, equating coefficient of x power n in both sides, we must get the same thing. So in this case, what will be the coefficient of x power, and in this case we'll be getting here c2n, x power n means it will be here n equals c0 cn plus c1 cn minus 1 plus c2 cn minus 2 and dot 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 cn c0. and therefore we just by expanding this, it is here 2n factorial by n factorial and n factorial equals c0 cn plus c1 cn minus 1 plus c2 cn minus 2 dot c and c0 proved. The whole digit we have here. Similarly, we can solve other questions. So this is the technique to solve this. Therefore, we have this answer. Thank you so much. Okay, so question number. Now let's move to question number F. So follow the same technique to get the answer. So now, as I told you just before, and then question number F, how to just I have seen how did I solve the problem in E number. So C naught square plus C1 square plus C2 square plus Cn square equals 2n factorial by, we have to prove this here, 2n factorial by n factorial whole square. So note here, or trick you can see here, trick to know the, or to have an idea to solve this. So constant means change. And here remember change means it is, that is, we have tried one time x power n, 1 plus x power n, next we have tried here x power 1, x plus 1 power n. This is how we will be solving this problem. Okay, so let me solve and show you. So as before, we have here 1 plus x power n equals how much? C naught plus c1x plus c2x square dot cn x power n, isn't it? This is what we are given. Now, as I told you, constant and constant means same means change. Okay, remember that. So x plus 1 will be simply here. What is happening here? It will, in place of a there is x, so it will be simply c naught x power x. So c, so just write here a equals, so it will be simply here a x power, so simply c naught x a power n minus r. So x will be here, and then it will be simply here x will take here, then x plus 1 a equals to write this. Okay, look here how to write this. What I'm going to do here, so we know, and then see right here x plus 1 power n will be simply c naught will be obviously there, so a power n, so c naught, so that will be power of x, so x1 will be here and c naught, so our formula is c n 0 and a power n minus 0 x power 0. So in this case it will be n power 0 means a power 1 minus a c naught 0 means here c n, a power n minus 1 means a power n minus 1 is n. So simply it will be here. Okay, look here, for x plus 1 it will be simply c naught x power n plus c1 x power n minus 1 plus c2 x power n minus 2 dot there will be at last cn. So how actually you got this? See here. So I'll just solve and show you. So tr, you remember tr is how much? Tr plus 1 is n c n r x, and then a power n minus r x power r, isn't it? So this is for a plus x power n. But if you write here x and a, you can interchange. So for x plus a, what will be the formula? So just simply here c and r will be as it is. So a will take place of, so it means here c simply a power, this here a will, so a power will be here a x power n minus r, and then a power, it will be simply r. So a equals 1, so it gives here C n r, and then x will be simply a equals 1 x power n minus r. So what we write here? So it means here C n 0 means here r is here. So r is here r is 0 n x power n. If you write here C n 1, so it will be how much? X power n minus 1. So C n 2 if you write, so it is here. So it will be simply here you can see there simply C n 2 and x power n minus 2. This is how we are writing this. Okay. Now let's multiply. We have the answer. Multiplying this, multiplying we get, so left hand side will be as it is, so 1 plus x power 2n, no doubt, and then right hand side. So see here c naught square plus this and this c1 square x power n plus c2 x power n. See here how we are getting x into x power n minus 2, so that will be getting here x power n minus 2 plus 2, it will give here x power n. This is how I'm writing. Okay, don't be confused, it's very simple. So dot 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 at last cn x power n, and this is whole square, and so many other terms will be there. We don't take these all the terms, so whatever we need we are writing here. So now what we can write here, actually this is c naught square plus c1 square plus c2 square dot 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 cn and x power n plus dot dot, so many terms. So now in this case we'll equating this is an, and this is an identity, so equating coefficient of x power n, we get here x power n. If we equate the coefficient of x power n, we'll be getting the result. Let me equate and show you. So x power n, the coefficient of x power n in left hand side will be, so c2n n, and then right hand side it is c naught square plus c1 square plus c2 square plus dot 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 cn square. Therefore we can write here c naught square plus c1 square plus c2 square plus cn dot 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 cn square equals simply 2n factorial by n factorial, that is 2n factorial by n factorial whole square. This is what we need. This is how we have solved the problem. This is our final answer. Hope you are getting this. Now last question, let me solve for you and explain it. Question number G. We have to prove that C0, C2 plus C1, C3, C2, C4 and dot 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 plus Cn minus 2 and xn equals, we have to prove that 2n factorial by n minus 2 factorial n plus 2 factorial. So as before, we can say here no change, that means here constant is there, C constant. Trick, how to start to get the correct answer. Constant means no change. Constant means this C will means change. Will change this. It means here 1 plus x power n equals how much? C naught plus C1 x plus C2 x square plus dot 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 Cn x power n, isn't it? So now change, constant means change, so it is here x plus 1 power n equals, it will be how much? So C naught x, already explained this, so n, now C1 x power n minus 1 plus C2 x power n minus 2 dot 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 dot, and then at last there will be, so again there will be, at last it is here Cn minus 1 x power 1, so at last there will be here Cn x power 0 is only simply Cn. So at last there will be Cn, it will decrease, and at last it will be 1. Now what we can do here, multiplying we get, so 1 plus x power 2n in left hand side, but right hand side multiplying this way. What do we need? C naught and C0. C naught here, C naught is here, and C2. So we get here C naught and C2 x power n plus 2. Remember, eh? So next one plus C1 C3. Let's see here, C1 C3. So C1 and C3, if you see here, C3 will be here x power n minus 3. Cn minus 2 before this n minus 2 x power 2. So if you multiply these two, look here, we'll be getting answer Cn and Cn minus 2 x power n plus 2. And then so many terms are dot. So now just equate the power of x to the power, what is there? Simplify here. So g number, so we can write here 1 plus x power 2n equals C0 C2 x power n plus 2. So let's take this as common, plus C1 C3 plus dot. We have here Cn minus 2, and the whole power is x power n minus x plus 2 plus dot. So we'll be equating the coefficient of x power n plus 2 in both sides. We get here C 2n and n plus 2 equals, it is here simply C naught C2 plus C1 C3 plus dot Cn minus 2 times Cn and equals, therefore we can write here C naught C2 plus C1 C3 dot plus Cn minus 2. Cn equals how much? 2n factorial by 2n minus n minus 2 factorial and n plus 2 factorial, which is 2n factorial by n minus 2 factorial n plus 2 factorial equals, this is the solution. You may be confused here how I wrote the coefficient of this x power n as direct. So it's simple, very simple to remember. Tr plus 1 equals how much? Ncr a power n minus r. So actually we have this in this case because a is 1, x power r. So direct we can write the coefficient of x power n plus 2 will be n coefficient of here. So note this. This is to remember, to understand only, x power r is simply ncr. We can write direct. Okay, this is how we have written. Hope you understood this, and if you have any confusion, please share with me. Thank you so much. God bless you.
Thank you so much for watching my video. I hope you like this video. Please do share this video with your friends, in your circle, in your social media, and please don't forget to subscribe my channel. Thank you so much. God bless you.